Hello everyone. Previously we discussed about the longest, this one common subsequence algorithm, right? Today we'll be discussing the longest increasing subsequence problem, right? With the we'll go with the DP approach, right? Dynamic programming approach. Here we'll be discussing about longest increasing subsequence algo, right? So basically it involves finding the length of the longest subsequence of a given sequence such that all the elements of the subsequence are sorted in the increasing order. So all the elements have to be sorted in ascending order, right? So that is how we find the longest increasing subsequence. All the elements has to be it has to be sorted in the ascending order. So also we will be making use of the DP approach or the dynamic programming approach, where we will maintain an array DP where DP of I represents the length of the longest increasing subsequence. So here let me write, we'll be making use of the DP approach and we'll be making use of the DP approach. Also we'll be maintaining the array DP array here, DP array where DP of I, this one iterated value of the DP will represent the longest increasing subsequence that ends with the element nums of I. This represents the longest increasing subsequence that ends with the nums of I. Ends with the element nums of I, right? So for each element in the array, we will compare it with all the previous elements to determine if we can extend the subsequence. Finally, we will return the maximum value in the DP array. So this is what we will be doing here. In the third step, we will be what we'll be doing here for each element in the array. We will compare this one with all the previous elements. So all previous element we'll be comparing with the all previous elements, and finally in the fourth step we will return maximum value in the DP array. So return maximum value in the DP array. So here we'll be returning the maximum value in the DP array, right? So this will be the approach. Let's write the code. Let's try to understand with the example. Also finally we'll discuss about the time complexity and the space complexity. So I'll just come here. Let me write here function length of longest increasing subsequence. I'll just take LIS. I'll just consider the parameter nums. Here first base case will be we'll check if the input array is empty. If input array is empty, we will directly return 0. So it has to be if length of the nums, if it is equal to 0, then we will return 0. Also we'll create the DP array that is initialized with 1 as the minimum LIS length is 1, right? So I can write in this way. This will be array of length of the nums and we will fill this one with 1. So finally here we are done with the this one initialization. Let's start iteration. We will start iterating over the array starting from the second element. Nothing but we will start with I equals 1. So here this will be I equals 1, I less than length of the nums, and we will increment the I. So let me consider j equals 0. So for each element we will be comparing it with all the we will be comparing it with all the previous elements, right, as we had discussed in the approach as well. So here I can write in this way. J starts from 0 basically, and j has to be less than I, and let's increment the j. And finally, if the current element is greater than the previous one, so whatever the current element that we are looking into, the current element, if it is greater than the previous one, then we will extend the longest increasing subsequence, nothing but LIS. So how can I write this? I'll just consider if condition. If iterated value of the nums is greater than nums of j, then I can just update the iterated value of the DP to the maximum of its current value and dp of j plus 1. I can write in this way. Rather than explaining, I'll just write this line. You just see this one, you'll understand. So we have to get the maximum of the current value and dp of j, right? So, and also plus 1 because we are starting with the 0. So here math.max of iterated value of the dp as well as dp of j, dp of I and dp of j. Finally, we are doing this one plus 1. I hope this is clear. Finally, what we will do, we have to return the maximum value from the dp array, which is the length of the longest increasing subsequence as we had discussed. So this one will be, we have to return the maximum value, right? To return the maximum value, I'll just consider math.max of, from the dp array, we have to consider the maximum value. So I'll just make use of the spread operator and I'll just give dp. So I hope this is clear. Now let's consider the example. This is it for the code. Let's consider the example and let's see if it gives the correct output or not. So here, const nums, I'll just consider some random number, 10, 9, 2, 5. I just consider 3, 7, 101. And let me consider this one here. Also, I'll just give result. Let's consider this one. What is the name of here? Let me give this one as length of LIS. So just give me a second here. And just consider the function name. What is the parameter? Nums, right? So this is fine. Finally, we will log the result to the console. So I can just write in this way here. Let me make use of template literals and the backticks here. Length of the longest increasing subsequence here. This will be, I'll just write within this flower braces. Let me give you a result. So I hope this is clear. So what will be the longest increasing subsequence here? Just give me a second here. Here the longest increasing subsequence you can see here 2, 5, 7 and 101, right? So you 3 will not be there. 18 we cannot consider. 10 and 9 is not in the increasing subsequence. So it will be 2, 5, 7 and 101. This has to be 4, right? The answer that we have to get is 4 here. So let's see what we get. So I'll just run this code. So yeah, length of the longest increasing subsequence, we have considered the length, right? So we are not considering the index basically. If we have considered the index, it would have been 0, 1, 2, 3. We should have got 3. Now we are considering the length. So length of the longest increasing subsequence would be 4. We are getting the correct output. So this is it. Thanks for watching, guys.